All right, so let's take a look at our first handout from Unit 1, which is linear systems. The reason that I start with these simple systems of two equations and two unknowns is that this gets us going thinking geometrically about the one thing that we're going to be doing all semester. And it also reminds us of what solutions to systems of equations can be. So let's take a quick look at these examples. Remember that geometrically, the solution to a linear system is going to be the points of intersections of the graphs of the equations. So the solutions are the points of intersection. Solutions are points of intersection. Oh, I already missed. Cheat a little bit. There we go. The solutions are the points of intersection in the equation. So if we look at graphs of these equations, let's graph this x minus y equals 1. So I'm going to graph this just by plotting points. We're going to set the Wayback Machine to elementary algebra. And let's see, if x is 0, y is going to be -1. So 0, -1. And if y is 0, then x will equal 1. If x is 1, y is 0. So that gives us one of the graphs of the equations. How's everybody okay? I know you're all thinking, dude, I am a professional Calc 2 student. I know how to graph a line. All right. Forgot my straight edge, so I'm gonna have to draw a squiggly line. All right. And the other equation, we got 3x plus 2y equals 8. So let's just write that in slope-intercept form. So we'll get y is equal to, let's see, -3/2 x plus 4. So I'll plot the point 0, 4, and drop 3 and over 2, and then we find the intersection. I also spend a lot of days teaching algebra, so I can't not draw the rest of the line. It's psychological scarring. So we can see that we had these two equations. Each represents a line, has a line to represent them, and the solution is the point of intersection. We get this point here, which happens at 2, 1. So we got exactly one solution at the point 2, 1. Any questions? How's everybody okay? First day is all got to look like a first day. It's like, oh, we're just going to graph some lines. So in this case, we got exactly one solution because we had two lines that were not parallel. So let's take a look at this second system of equations. We've got the same equation. We've still got the x minus y is equal to 1. So I'm going to plot that same line. Because I'm just trying to be green and save space. So that first equation in this second system is x minus y equals 1. So I'll draw the same line, a y-intercept of -1 and a slope of 1. With the second equation, I've got -x plus y equals 1. So if we solve this, or sorry, if we graph this equation by plotting intercepts, because it's set up so easily to do, if x is 0, then y is equal to 1. And if y is 0, then x is equal to -1. So we got the point 0, -1, and also the 0, 1, and also the point x is -1, 0. So what we see here.
You might need to check the settings.
What we end up here
没有
is
啊，
parallel lines.
是吗？
Since parallel lines do not intersect, we have no solutions. Any questions? All right, so we ended up with no solutions in this case because the two lines were parallel. In the third system, we have the same first equation, x minus y equals 1. So I'm going to plot the same line. So we have the same line, a y-intercept of 0, -1, and a slope of 1. And now our other equation we can see is going to be the same as the first equation. It says -x plus y equals -1. And if we graph that line, it's the same line. If we multiply through by -1, this is the same as x minus y equals +1. It's the same line. So that graph is going to be sitting right on top of the first graph. So what we have in this case is infinitely many solutions. So in this case, we have infinitely many solutions. Any questions? The reason that we went over these three examples, even though they are very small, about as small as we can get with a system with, as small as we're going to see for a linear system. These three examples cover all the things that can happen, all the forms of a solution set for a linear system. A linear system can have one solutions, no solutions, or infinitely many solutions. So these are the three possibilities for the solution set for a linear system. A linear system will have one of these three possibilities. The solution set for a linear system will fall into one of these three categories. The solution set for a linear system will be one of these three, either one solution, no solutions, or infinitely many solutions. So we have words for these things because this is math and we always have words for things. In the case where a linear system has no solutions, we'll say that the system is inconsistent. If the linear system has at least one solution, then we'll say that the system is consistent. So down here, infinitely many solutions, that means there's at least one, so this system is consistent. Any questions? So first important thing, solutions are intersections. Second important thing, the solution set will fall into one of these three categories. And third thing is wording. Those three categories are inconsistent for no solutions, consistent with one solution, or consistent with infinitely many solutions. Those are the only three things that can happen in a linear system. So you can't have a linear system with just two solutions. If there's more than one, there are infinitely many. How's everybody, okay? Because you're all looking at me like, well, actually, your names. I can't even tell if you're all looking at me at all. All right. So let me pause recording for that for a minute.